Okay, so artificial intelligence, machine learning, data mining, data analysis, clustering, classification, data pre-processing, big data. It's hard to go anywhere now without hearing about AI and machine learning and data particularly. It's everywhere. Researchers suggested that every 2 years we generate more data than has ever existed before. So the amount of data is doubling every 2 years. Now that is an absolutely astronomical amount of data. But the thing is, of course, that this data doesn't necessarily mean anything. In fact, you can create tables of data, but unless you understand what's in them and what they mean, you haven't got any knowledge. Right? So there's a distinction between having data and having knowledge. It's all very well saying, yes, as a species, we're producing a huge amount of data, but actually a lot of it doesn't get used. Right? A lot of it sits there on a hard disk waiting for someone to look at it. Right? And that's kind of what we're talking about here. If we want to extract knowledge from data, we're going to need some tools and processes to do this in a formal way, and that's what data science is. Right? And things like machine learning and AI have a place within it. So perhaps if you do this for your job, then data analysis is going to be useful for you. Maybe your company's generating data and you want to analyze this data. But on the other hand, perhaps you're just a consumer and companies are using data on you, they're generating data on you, and actually they're profiting from data on you. These are sometimes life-changing decisions that are being made on your data, and so it's empowering to know how this process works. Another very simple example, which you might even do yourself, suppose you go online to book some flights for a holiday, and then you decide that actually 2 flights via an intermediate airport is cheaper than a single flight, right? You're doing data analysis there. You're taking lots of different data sources and working out the optimal route. And this, of course, happens automatically as well, depending on the flight website that you're using, right? So this kind of stuff, you're already doing it, right? It's just a case of trying to formalize this process. So what do any of the things that I listed at the beginning mean? Well, one problem is that everyone's definitions differ slightly, but also I think that a lot of these terms are used completely interchangeably. AI is the classic example. So AI is everywhere, right? You can't buy a product without it having AI added to it. A lot of the time you see AI, we're actually talking about machine learning. So machine learning is the idea that we're training a machine to perform a task without explicitly programming it to do so. A good example of AI that isn't machine learning would be, let's say, a mouse in a maze, where all you're doing is telling it to turn left or right at random. It's not learning anything, it doesn't understand what the maze is, but it will eventually get to the end, right? That's a kind of rudimentary artificial intelligence that doesn't involve learning anything, right? Machine learning is about not giving it conditions, not saying if you're here, turn left, if you're here, turn right. It's just giving it examples and hoping it will learn to perform those tasks itself, right? So machine learning is a subset of AI, but they shouldn't be used interchangeably. If we're using machine learning, often what we'll do is we'll train it based on samples of data. So we'll have some existing data set that we're trying to train on, and we're trying to use the machine learning to either tease out information or make predictions on this data. The problem is that not all data is sort of made equal. Some of it's noisy and messy. Maybe we don't know what it is and don't know whether we can apply a certain technique to it, right? And so we need to clean this data up. We need to take this data, understand what it is, and extract some knowledge so that we can then apply these AI or machine learning techniques to it. So this combination of things that can take data and prepare it in a way that we can then use it or understand it, that's data science. There are quite a few ways we could do this data analysis, right, throughout this course. We could use R, we could use Python, we could use MATLAB. They all have their pros and cons. We're going to use R because it's free and it's really good for statistical analysis. It's got loads of great libraries. If you're really familiar with Python, then maybe that's what you want to start with for this kind of stuff. But we're going to be working with R. We have our script area here where we can write scripts and run scripts. You can save them and then come back to them later. Console, where we're going to be putting in specific commands. We have our environment, which is where all our variables and our data is held, and we can look at them there. And then we have plots. Any plots, of which you can do quite a lot of different plots in R, very versatile, that's going to appear down here. Okay, so you've kind of got everything you need to get started with data analysis. In my opinion, the best way to get into R is just to kind of have a go. Right? So we're just going to look at a few of the most obvious things that it does. It has a little bit of a learning curve, only because its syntax is slightly unusual. If you can program, you'll be fine, but even if not, you should get there pretty quickly. Most of the time in R, we'll be using either matrices or vectors, which are kind of a special case of matrices, or maybe data frames. Data frames are a really nice aspect of R, which you can kind of think of like a table like you might have in Excel, except you've also got headings for your columns. So let's have a look at some of these things and just a few of the things we can do with them before we perhaps go into a little bit more detail in other videos. So, for example, we might look at our variable x, which I've created, and x is a sequence going from 0 all the way up to a few multiples of pi, which I used to create this plot. That was only one line of code to produce that, and I've used that to create my plot by essentially saying y equals sine x and then just simply plotting that. If we want to get a little bit more complicated, we can start looking at matrix data. So I created a CSV file with a Gaussian function in it, so essentially a two-dimensional array of values that get bigger in the center. Right, very straightforward. A CSV file is essentially a text file with commas separating those values. Very easy to read and write these out of Excel and other packages, and so you'll often find data is passed around in this way. At least moderately sized data if it isn't too huge. I can load this in using my read CSV function. So I can say name data. Now the arrow operator is essentially the equivalent in R for the assignment operator, so equals. Equals will often work, but I tend to try and use this one. So name data, I'm going to assign read.csv, and the file is going to be norm.csv, and I've got no header for this file, so I don't want it to use the top row for the labels, so I'm going to say header equals false. And that's loaded in name data, and we can have a look. So I'm going to click on name data here, and if we click on it, you can see we've got the rows and the columns of our data in here. We can look at individual elements in this array, so we can say data at position 3, 4, right? And that's going to be the third row down and the fourth value across. We can also leave one empty and just have an entire row, or conversely, an entire column like this. And so it's very easy to take ranges of values. You've got a huge table of data, selecting certain columns, looking at certain columns, plotting certain columns. This is one of the reasons why R is very popular. Quite often when you're looking at data, we'll actually be looking at something called a data frame. Now a data frame, I'm going to load one up, is simply in essence, a table of values, but they don't all have to be the same type. So in an array, normally they'd all be floats or they'd all be integers. In a data frame, they can be different things. So you could have first and last name next to age, for example. So I've just created a tiny little CSV file with some random people in it. So let's load this up. So I'm going to say name data, assign read CSV, names.csv. And if I look at name data, you can see that it's got 3 columns. It's got first name, surname, and age, and 5 rows, so there's 5 people in this data set. And then you can do just like I did before, but now we can also index by the names of these columns. So I could say I want all of the first names, for example. So I can say name data $ first name, and I can see all the different first names. So you can start to look at this data set in more detail. Obviously this is an absolutely tiny data set, but you get the idea. You could also look at individual instances. So we could say name data, and I want just the second row, for example. Name data, the second row. There we go. Bill Jones, and he's 18 years old. As we move through these videos, it's going to be very common for us to load in data sets like this, in this format, and then start to process them based on these data frames. So perhaps an example, right? So let's imagine you're an online retailer and someone comes into your shop and buys some things, and maybe you're trying to understand what it is that they do so that you can, let's say, send them emails to try and get them to buy more products or show them recommended products and things like this. So you want to try and build up a pattern of their behavior, right? And all you've got is what they click on, what they add to their basket, and what they buy, right? So you've learned that they're looking at these kinds of items, and they look at these ones regularly, and then sometimes they just buy something completely random, seemingly, and that goes in their basket and gets bought straight away. Maybe it's a present, right? So maybe it's not tied to them as a person. So you're taking all of this data, all of these purchases, all of these products that they're looking at, and you're turning this into a kind of picture of this person, and you're clustering that person in with other consumers that bought similar things, and trying to predict what they want to buy next, right? And that's when you send them an email and say, you should look at this one, because this one's really good, and you didn't buy it last time, but you'll definitely want to buy it this time. So we've got some data, we want to extract some knowledge. What's the first thing we do? Well, we have to start to look at it and try and tease out some kind of information, right? Or analyze this data. So data analysis is the idea of using statistical measures to try and work out what's going on. This is kind of a cycle. We're going to analyze the data, so we're going to do data analysis, and perhaps sometimes just using statistics to analyze the data isn't enough. You can't really learn everything about it. Yes, you can learn, mathematically how it works, but you might not understand about what it all means. So visualizing the data can be really helpful. So what we'll also do is we'll visualize the data, visualization. So that's going to be charting it, plotting it, trying to work out trends and links between different variables and things like this. And these are kind of be a back and forth, right? You could do both of these things numerous times and work out what we've got, right? So you're going to do something like this. And then what we're going to do is we're going to pre-process the data. Often you'll be finding you're recording much more data than you actually need. Right? This is certainly true of an online shop. I'm going to be looking at a lot of products that I don't end up buying, and I was never really going to buy, I don't know, maybe a pipe dream. And they've got to sort of weed out this information to work out what it is that they might actually be able to convince me to buy. Right? So this is you're going to pre-process the data, remove the nonsense, and drill right down into the stuff that's really useful. So this is pre-processing. And this is going to be a kind of cycle of analysis and visualization and pre-processing, and we can repeat these things, and then we can really drill down and whittle down our data into the most usable sort of core of knowledge that we can, right, and get the most out of it. Now, it may be that just analysing the data is enough, right? You've obtained some knowledge, you kind of understand what the trends are, and maybe that was all you wanted to do, right? That's sometimes the case. Maybe actually what we want to do is take things a little bit further. We're going to use machine learning or modelling to try and model this system and predict what's going to happen next. So, for example, in the case of an online shop, we might want to start predicting what people are going to buy next. And if we can do that, that's when we can send out these emails or flag things in their recommended items and get many more sales. As an example, let's imagine that someone has spent a lot of time looking at DIY tools, right? I've recently moved house, I've spent a lot of time doing DIY, and I'm always trying to buy new tools because it just seems like a good idea, right? So maybe I buy a certain kind of saw, and then a few months later they're starting to recommend me a slightly different kind of saw that serves a slightly different purpose that suddenly I definitely need to be doing, and I think, yeah, maybe I will buy that. And in the end I have 10 saws and I don't know how to use any of the saws, but the retailer's job is done. If we want to extract this data, we're going to use machine learning or modeling to model this system and make predictions. Right? Now, so for example, we could cluster the data together. We could link my purchase history with similar people. What are they buying? Can I be tempted to buy those things as well? Right? Maybe I'm very different from someone else, and so it's not a good idea to recommend me certain products because I'm unlikely to buy those things. Perhaps to use a different example, in the medical domain, it's quite common to classify people into kind of risk categories, right? So that we can maybe use preventative treatments. So every time I go to a doctor, they're going to collect data on me on what's currently wrong with me and what was wrong with me before, and combine that with standard data like how much exercise someone does and their family history and what their stress levels are and things like this. We can combine all these things to make a prediction as to what they're at risk of in the future. So heart disease or something else like this. It could save someone's life if you spot that they're at risk of a certain thing, and you can really advise that person to increase their level of exercise or alter their diet. There are two other terms that we come across a lot, right? So there's data mining and big data. Right. Now, I'm not really sure what data mining is because I don't think anyone is. It's a bit of a buzzword. Really, what data mining is a combination of pre-processing your data and maybe using clustering to extract some knowledge from it. Right. So that's it's a word that's come to be used in place of those things. Right. If someone says they're doing data mining, that's what they're doing. They're pre-processing and extracting some knowledge from their data. Right. It's a cool sounding word. You're not actually mining anything, right? You're just doing what everyone else does on data. Big data is the idea that maybe we've collected a lot of examples of something, a huge number, or each of our examples is quite complicated and it has a lot of variables, right? In that case, the amount of data we've got is sort of unwieldy, right? So I would argue perhaps that big data is not data that you can run on your laptop, right? You might be using cloud compute infrastructure or certainly parallel processing in some way to pre-process and analyze this data. Right? So exactly where the line, how big is big? Right? I don't know. But exactly where we draw the line in some ways is not really important. Right? The idea is just that the amount of data we as a species are now producing, more and more of our data is becoming big data. Exactly where the cutoff doesn't really matter. What is data? Right? I'm pretty sure that's data. Right? Is this data? This picture? Or that data? Is this data? What is data?